We're looking at engine efficiencies, and you recall that we had the PV diagram that we talked about for an actual Otto cycle or a spark ignition engine or a diesel cycle, and they look like this, where this is the compression stroke, combustion, etc. And so when I look at the actual PV diagram, this represents the work that the fluid indicates it does on the piston. So this is W indicated. So when I have a piston cylinder, and we have the injectors, the various valves. So what's happening is that I have a pressure pickup here. So I have a pressure pickup, and what happens is the piston moves. I'm able to create this PV diagram. So this is the work that the fluid indicates it did. Then if we have the engine itself, so now I have the engine itself. And it has a shaft. And so the shaft is rotating, and this is the brake work. Brake work or shaft work. So this is the brake work or shaft work, and that's the actual work that you get out of the engine. So the fluid indicates it did something, it moved the piston, the engine gets some, so part of this gets converted into brake work, and then we have the theoretical work that we did with the air standard cycles. So we have W dot theoretical from air standard. So from the air standard cycles, and we've spent time doing that. And the difference between the indicated work and the brake work is the work lost to friction. So we have, is our frictional work. So this is friction, and or the work lost to friction. So W dot I minus W dot F is equal to W dot B, the brake work. Now we have various efficiencies. We've introduced the mechanical efficiency before when we looked at compressors, but let's go back there again. So we have mechanical efficiency. Eta sub m. And this is your brake work over indicated work. So it's W dot B over W dot I. We have the brake engine efficiency. And this is why I said we have to look these up, because I can't remember these unless I look at the definitions, and I've been doing this a lot longer than you've been doing it. And so let's look at the brake engine efficiency. And so this is Eta sub B, and this is the brake work over the theoretical. So I have WB over W theoretical. And obviously these can be on a time basis as well. We have the indicated engine efficiency. And as you might imagine, this would be the indicated work over the theoretical work. Wi over W theoretical. And then we have, continuing on with efficiencies, we have the brake engine efficiency, and we use these somewhat. The brake engine efficiency, I think we use more often. So we have the brake engine efficiency, brake engine thermal efficiency, ATIS of TB is equal to the brake work over energy in. And so this is equal to W dot brake divided by M dot F H sub RP. So what we have, so in this case, this is the output. So this is the energy output, the useful work that we got out of the engine. And this is the energy that's provided by burning the fuel. So this is the fuel energy that's provided, and how well that conversion occurred is your brake engine thermal efficiency. And we have the indicated thermal efficiency as well, where we are going to have the indicated work here. And so we have the indicated thermal efficiency, where I have ATIS of TI is equal to the indicated work over energy in is equal to W dot I over M dot F H sub RP. And so these are the various efficiencies. I look them up in the book whenever I'm given information about them, as we will be given in a problem that will start in just a little bit. One of the things that happens is, how do we measure brake work? So what we want to do is, we have an engine that's rotating. How do you measure the output power of that engine? And so let's look at power measurement. And so we want to measure engine's power. And so we'll say brake power, brake or shaft. So we're going to use a dynamometer. So if I look at a dynamometer, I'm going to have something like this, and I'll have the engine hooked up to this. So I'll have the engine hooked up to this dynamometer. So it's going to be behind it, and the dynamometer I'm going to show with force, but a lot of times it generates electricity, etc. We can measure it in a variety of ways, but I want to show you using torque and where that comes from. So I'm going to have the dynamometer, I have a shaft, and from here I'm going to have something that rotates around the shaft. In the text, there's a different diagram. It's for a Prony brake, and it's for very small engines. We can use something where you basically have a brake shoe that you clamp on the shaft, and when I clamp it on the shaft, it'll spin and create a torque in this sort of force. But in any case, in this case, there's a load cell. I have an arm that comes off this rotating shaft. So I have this rotating shaft here. I have this arm, and here I'm going to have some sort of reading, and this is exerting a force downwards, and I have this at a radius r. So this is the distance, and if I imagine I have a wrench, if I have a wrench, I have a force, I'm pulling down, it has a load on it, and it's at this distance. So that's what we have. So the work per revolution work per revolution is equal to 2 pi RF. And N, so that's what this is. N is equal to the revolutions per unit time. And the reason I use unit time is that typically if I'm measuring power in English units, I'm using minutes, and in SI units, I'm using seconds. And so I have that the power is equal to 2 pi R Fn. And then the brake horsepower the reason I do this is that you hear people mostly talk about how many horsepower an engine has. So we don't say how many kilowatts do you have. Maybe if you have a Tesla, you say that. But mostly what you talk about is what's the horsepower of your engine. The engine has 150, 200, 400, whatever. And so if we have the following for horsepower. So I'm going to have R is going to be measured in feet. N is RPM. And F is pounds per. So these are the units that I'm using. And then the brake horsepower is equal to 2 pi R Fn divided by 33,000. In the 33,000 is the conversion of foot-pounds force to a horsepower. So this is 33,000 foot-pounds force per minute per horsepower. And so anyway, so when coming out of here, I'll have the units on this in bhp. RF, so this product, RF, is called the torque.